Draft physics video. Figure I better make this now because might not be able to later. Snow coming and whatnot. Well, snow happening. Let's see what happens. It's usually bad news here. Snow. No electricity and all that crap. But anyway, so been thinking about this whole velocity thing. Quite interesting when you really start to think about it. And I'm really thinking about it just in terms of this idea of spinning something, just turning it around. And if it has a velocity, that's sort of a lot of change, and yet it's not realized as much of a change. I mean, even for the relativists who believe in length contraction, if you turned in their length contracted world, you would go from being, contracted in one direction to being contracted in exactly an opposite direction, and it would be, you'd go through this uncomfortable process, you would imagine, of, being compressed in, one way, making, and then bulging again, and I mean, it's it's a warp of some kind. You could imagine it as uncomfortable. Velocity, as I see it, is something you acquire. It's a force that you possess when you have it, and that it's a universal thing. The whole frame thing kind of breaks down because it sort of means that I can't throw a baseball through the universe without it going through a bunch of frames and somehow, doing a bunch of diffracting of some kind to get from one frame to another, and that it's not really going to be traveling the line I threw it at. And I'm also kind of a believer that the universe, there's one universe, that the little bits inside of us are in the same universe as the big bits, and we just have this illusion of a separation between the two universes, and it's just that, an illusion. It's not real. It's just as dark inside, as it is out there, and desolate, and all of those kinds of things. So, but my idea would be is that velocity is like you're storing force. So it's like a storage mechanism. You're like a spinning wheel, except they're like, say, on a road, but the road can only hit from the bottom. It can't come up from the top. In other words, you can't go this way. You can only go one way. The force will only let the battery can only drain in one direction. So it's like a spin, and you say, yeah, but you can only release the spin this way. It's like having Earth in an orbit and saying, no, you can spin the Earth all you want, but when you release it, you can only release it that way, on one side of the curve. And that's sort of my vision of what velocity is that it's not something you can destroy. You can't just spin around and change your velocity. If you're moving this way, spinning won't stop you from moving that way. And so it's a permanent kind of thing. It's a thing that survives the spin, the turning. So it's like a glass of water, or a glass of some sort of mixed fluid, different colors, let's say. So when you turn the glass, you can see that the fluid doesn't necessarily pay any attention, because the tension breaks down and the glass can turn without the inside of the stuff inside turning. And so I would argue that there's parts inside of us that obviously don't turn when I spin around in this chair. They're not paying much attention. So I was thinking about where that line might be. Obviously my arms are paying attention. Okay, they're sort of obligated. My liver, it's going to be obligated to go where the body goes. But I was thinking maybe a blood cell in the fluid that might not have to change its orientation. I mean, the world around it will turn, but it doesn't necessarily have to spin with it. So it can be going head first. I'm going. And then it can be going tail first through the artery or the blood vessel. And it might not care. might not be any obligation to change, to apply torque to it, to change its orientation. And so this gets down to the little elemental bits eventually, like everything. That's where everything's really happening, is the little tiny nuclear stuff. I mean, I've argued, sorry. It's not really something in my throat. It's like my throat has ceased to become a throat. I'm being strangled from within. Demons or something. Anyway, so the little atoms and stuff, what's their perspective? I mean, how bound to the exterior, the mechanism that's turning, are they? How obligated are they to turn molecularly with the turning? And I mean, you can sort of clearly you can sort of perceive that, as you go through more and more of these places where there's tension between two things, something that locks them together, that can break, that you can see where the breaks might happen in those little systems, but you'd think that'd be very disruptive, to have all these little bits of tension inside of us have to snap and reorient all the time. But then again, we evolved on this planet, so that's a condition of surviving on Earth, would be tolerating the fact that you will move through an environment, and no matter how straight a line you think you're walking, the Earth, the orbit around the sun, the orbit in the galaxy's orbit in the cosmos, is all obliging you to constantly have a new orientation, in a sense, to have little magnets inside of you that are turning, twisting all the time. I mean, you could imagine if we were made of little magnets and they were oriented to the Earth's pole, that spinning you would be a real problem, because it would just start ripping everything to pieces as all the little magnets individually turned. Yeah, so it's an interesting quandary. I mean, I had a theory of inertia, and I still have it. I'm not too concerned. But it does create, it does make it seem more difficult to explain how you could have this much change without it meaning anything in terms of any kind of structural breakdown. Like everything just works. I can spin around just fine, no problem. Part of the problem is that any spinning we do is really slow compared to the speed of the little bits. I mean, they're living in a much, much faster world than we're in. And it's not even just a relativity thing. Although that would be part of it. The fact that we do have velocity has slowed us down, so to speak, in terms of perception or clock speed or any of that kind of nonsense. But we're, it's just the very fact that, the little bits are moving in this speed of light context. And compared to the speed of light, this turning is very, very slow. And I wonder how fast you could flip something where, the jolt might mean something to it. But then you're getting into centrifugal, acceleration. And that kind of spoils that deal. Because you want to kind of just see what it would like to be instantaneously reversed without you having to accelerate half the bits in opposite directions. This acceleration is always much more noticeable. So I haven't resolved it yet, but it's been useful in terms of it's stuff I hadn't thought of, and and the idea of a one-sided spin is sort of necessary to the idea of having a gyroscope kind of thing. So I guess that's one way to look at it, as gyroscopes. But, if you had a bunch of gyroscopes and they were part of one big gyroscope, if you moved the one big gyroscope and turned it, the little gyroscopes probably wouldn't care. I mean, they're not going to be bothered reorienting themselves. But the torque thing is the thing that just got me, because I was just thinking about the fact that when you're holding a wheel spinning, even a hard drive, and you move it, you can feel the torque of changing its position, flipping it. Flipping it, you'll feel the torque of doing that. It won't be a free thing you just did. And so it seems pretty impossible that all the spinning bits, the gyroscopes, if they were connected into the matter in some sort of rigid way, that there's any way you could reverse them without you feeling the torque of reversing them. So, I don't know if there's anything else I have to... I mean, I've just been dealing with just conceptually trying to, trying to resolve, trying to find a solution, that's, that explains how you can carry so much mass. And see that even the relativists believe in this kind of stuff, that you gain mass when you gain velocity. And that it's a real thing that's happening. And so clearly I'm saying you're gaining this force, which equals to mass. It's not held as matter, it's held as force. And it's force in one direction, the direction of this momentum, this inertia in a direction, this thing called velocity. So velocity is kind of like voltage. So the electric universe guys could make something out of this in the sense that when you possess a velocity, it's like holding the potential of electric potential. It's increased your power, and it seems clear that that's true. That you're carrying more mass, especially in one direction. I mean, it's that the matter you have is obviously moving, and it's all moving in one direction, which means that it's obviously, as a probability, it's more likely to hit you going the way the velocity is going than the opposite direction. So it has like almost zero potential to harm you from behind, and a huge probability of hurting you if it's coming right at you. So it's like all its mass is now pointed in the direction of that velocity, and its mass in any other direction is a lot less tangible, a lot harder to find. You have to you can't throw a 10-mile-an-hour baseball at one going 30 miles an hour away from you. The two masses won't have anything they won't interact. No mass potential. You have to throw something faster and faster and smaller and smaller. All right. Anyway, that's probably another subject. All right. Yeah. So it's just about this idea that that your velocity doesn't care about how you're turning most of your matter. Most of the bits are getting turned, and yet the bits that matter, the littlest bits, somehow aren't being turned, because if they're the ones that are possessing, directing the force of your velocity, holding the key to it, however you want to say that, they obviously can't turn, or you'd have a new velocity, and you don't. It's like falling off a building. You can go feet first, or you go head first. And you're not going to feel that big a difference in terms of the falling either way. I mean, there will be some difference, but yeah, it's just not that big a difference. And that's, again, the only reason why you're feeling a difference is because you're accelerating. I mean, they call it free fall, but you're accelerating. You're gaining force. You're gaining potential. I mean, somebody might argue you're converting it, but I don't think that's true. Yeah, if you were converting it, that would mean you would have more potential the further away you were from a gravitational source. And it's like somehow you've given up potential by moving closer. And, there might be something to that, but I don't think the answer lies there. So anyway, it was just curious. The distinction between the physics of acceleration, the acquisition of velocity, and sort of like the idea that, we're accelerating, but the fact is we don't accrue velocity down. We just keep accelerating, and then we get pushed back up, and then we accelerate, and then we push back up. So we're bouncing, essentially, but we don't feel that much. I mean, we certainly feel something's happening. But yeah, the acquisition of velocity is clearly a different kind of process than the possession of it. So a battery filling up is different than a battery full. Yeah. It's certainly a more aggressive process to put the energy into something, like gasoline, than it is to just store it. The storage doesn't seem to have a consequence. Doesn't seem to make itself known as aggressively as the process of releasing and acquiring. Acquiring. It's a good word for acceleration, in both A words there, Acquiring velocity. Yeah. Anyway, I keep saying anyway. Yeah. So I've just been sleep thinking about this, and so I haven't got there yet, but just thought I would throw it out there. I don't know. Well, here's I might as well just do a brief one on what I'm speculating. I've sort of pointed this out before, but what I'm speculating to be the way your velocity is stored in matter. And so I think it's stored in atoms. And essentially it's stored in the sense that the force is acquired between these electrons. And so the electrons establish a current. And the point is what they do is, through their magnetic forces, they thicken these forces. And because there's more matter, like more bits, so more electrons involved on one side of the equation than the other side of the equation, there's a potential in this direction, because more of the matter is force bound on one side than it is on the other side, more of the relevant nuclear bits. And because of this current, there would be likewise a similar increase in this kind of stuff, and that would, between the protons and the electrons. But that's the idea of the wheel. So you're spinning a wheel that has more mass on one side than it has on the other side. You're pushing a current. Well, I use the idea of a paddle wheel or something. You have more paddle wheels on the stream on one side than you have on the other side. And so the water is pushing more mass in one direction than it is in the other direction. And it's really about this idea of pushing mass, pushing the material that is you in the direction you need to go, because all your bits are moving in that direction. And but it just gets so saying that each one of these atoms is essentially a local field kind of solves the problem. You just say, well, it's a local field, kind of like the blood cell in the fluid. And if the fluid spins, the blood cell has discretion. It doesn't necessarily have to spin with it. So you could argue that these collections of momenta can be associated with each other, and everything can spin, and they'll just move around each other, but they all still carry the same potential to move a lot of mass that away. If this square breaks down, if this circle breaks, the break will mean more, like if I were to kill these little lines, I mean if I was to kill the relationship between these things, and so you would just go based on what the last force was affecting something, the point would be is that these would all have velocities in this direction, and you'd only have one bit with velocity in the other direction. So that's the point I'm making, is that when you break it, more matter will be going this way than is going these other ways. And that's also conservational and makes sense. But it's just where does the tension, the torque, the bonds get liquid enough, get weak enough, where you could rotate things around each other by spinning something. So even though this pen theoretically is moving whatever 1,000 miles an hour on the surface of the Earth, I can rotate it. It's still moving 1,000 miles an hour, whatever direction the rotation is. And that part doesn't change. It's still moving this way, even though I keep turning it head to foot, head to foot, head to foot. Even though 1 minute it's, you know what I'm saying, its head's pointing that way, and then the next minute its tail is, next minute its head is, and the next minute its tail is. And what's moving inside here, and what's not moving inside here? What gets rotated, and what just spins where it is, and just ignores the rotation. Yeah. So what's yeah, sorry, there's got to be a better way to do this. I mean, there's got to be a better, I guess that's what I'm seeking, is a metaphor. Eddies in a stream don't really work, because they are always in kind of quiet places. I mean, next to aggressive places, but they're always quiet where they are, and they're just peacefully spinning in their little local area. And so I suppose that works in some sense, where you could say each atom has a local environment, and its bonds to the other atoms is just a vague bond, like a weak force, a weak gravity, and it's not going to be obligated to change its routine in that weak gravity. I guess you could argue that the moon going around the sun isn't very affected by the fact that it's it's getting more gravity from the sun on one side of its orbit than the other side, because its orbit is too narrow for the difference to matter. So it sort of doesn't care, and it doesn't care about the rotation around the solar system. But obviously inside of the moon, if you were to break all the bonds at once, just break its connection to the Earth and break its connection to the solar system, and then break its connection to the galaxy, it has an absolute velocity that is the combination of all those force acquisitions, or whatever you want to call them. Yeah. So anyway, well, I have to do more thought on it. I mean, it gets very complicated, because there's people spinning in chairs, on a platform that's spinning. on another platform that's spinning, on another platform that's spinning, and it's, you know, it's pretty hard to figure out what parts care about what other parts are doing at all. So anyway, I guess it's a depth question. But I mean, once you start thinking about that apple to the earth as an atom, you know, to an apple, you know, you start realizing that these little bits are so separate from what this big bit is doing, what this body's doing. You know, there's about, you know, I mean, look, an apple to the earth. And I'm made of how many apples? You know, 10,000? Well, no, it couldn't be that many. 1,000 apples, let's say. You know. So that's, you know, earth to apple. Atoms to apple. So I got 1,000 times that whole earth to an apple thing 1,000 times. I mean, it's just a, you know, the granularity of the sand. You know, sand's probably a good metaphor. You know, because sand shifts so poorly. I mean, the bonds between the little grains breaks down so quickly. So you could sit something in the middle of a pile of sand, and then you could have that in a bucket of inside a bunch of. I mean, you could spin the bucket. The thing in the middle just sits there. It says, I'm not noticing anything. So anyway, yeah, so it's just I mean, it's not necessarily a pleasant distraction to have to think on this. There was other subjects I wanted to work on. But it still is tremendously related to this whole subject of what's happening with light and the speed of light, and being able to measure to establish that a photon is something we know to be, say, universal, that it has no identity issues. It does one thing, moves in a straight line in one direction, and the whole question of why we can't produce this perfect thing perfectly. You know, anytime we try to shoot one straight, we can't do it. And maybe that's just because the gun is moving too much. And so we just never can do it, because we're always shifting our velocity, which is shifting the little bits aren't moving with our movement. So they're staying oriented where they're going, and we're turning them, pretending we can shoot light this way, when the little bit is saying, I didn't do that. Something like that. And so every time we change the trajectory of our absolute inertia, velocity, it's constantly changing, and as it constantly changes the aim of the gun, so to speak, the orientation of the electrons. Yeah. And such. Yeah, okay. So, just kind of, yeah, draft science kind of a video, because I'm still thinking on it.